Hello learner, I am Soumojit Roy, Assistant Professor of Huldia Institute of Technology from the Department of CSE and AIML. So today our topic is understanding kNN algorithm, which means actually k nearest neighbor algorithm in machine learning. So let's start our learning journey, and so let's move on to the next slide. Right. The first question is, what sort of machine learning algorithm is this? kNN is a The first point is kNN is a supervised learning. So the question may arise, what is supervised learning? Supervised learning is a type of machine learning algorithm where the model is trained on a label dataset, right? So now the question is, what is label dataset? Look, it's actually means that label dataset actually means that for every input means feature columns, the corresponding output or the label, right, is actually provided, right? So we can call our input columns as our features and our output column as label. Now the algorithm in supervised learning, the algorithm actually learns a mapping from input to output by minimizing the error between the predicted and actual levels, right? That is during training, and that is the working principle of supervised learning. So supervised, this is very easy. Supervised learning is actually working on the label dataset. What is label dataset? If we have the input columns and feature and the output column or label, this is actually called as a supervised learning, right? So kNN is a supervised learning. Why this is supervised learning? Because we need label dataset to train this algorithm. On the other hand, what is unsupervised learning? The unsupervised, if we don't have that kind of input and output column, that distinguished input and output column, this is actually called as a unsupervised learning. So what are the example of some unsupervised? Any kind of clustering or principal component analysis as the example of unsupervised learning. But kNN is a supervised learning. Why this is actually called as supervised, labeled as a supervised learning? Because we actually it's actually working on label data set. That's why, right? Now second question is, the second point is not the question, sorry. The second point is supervised learning have two types. The first one is classification and the second one is regression. What is classification? Classification, if our output like level data, right, if our output is in in the form of discrete value like yes, no, right, cat, dog, horse, that kind of things, if we have the discrete data as our output column, this is actually called as classification. So in classification we actually predict the discrete values or the categorical values. So this is actually called as classification. On the other hand, what is regression? If our model predicting a numerical value or a continuous value, this is actually called as regression, right? The second point is, kNN is a classifier or regressor. The first point is very clear, kNN is a supervised learning. The second point, now the question is kNN a classifier or regressor? kNN works as a both. It's a classifier as well as the regression. Now our point is very clear. In gist, we can say kNN is a supervised learning which can used as a classifier as well as a regression. So it can predict the numerical value, it can give an output in the terms of the numerical value as well as discrete values. Like it can also classify, it can also predict the numerical values. So this is very clear. Now the second point is, what is the working principle in one line of kNN, right? Look, we can use the principle to classify the data by placing it in the category with the most similar nearest neighbor. It actually look after the nearest neighbor and then finding the pattern of the nearest neighbor and then classify the output data, right? So that is the working principle of kNN, right? So Again I am repeating that it's actually look at the nearest neighbor or the nearest points, and then it try to capture their properties, and then it classify the output data, right? Now the what is the application of kNN? The application, we can use the kNN algorithm in the computer vision application, right? Including the optical character recognition, the facial recognition, any kind of deep learning. We can use the this classical machine learning algorithm, right? So if we have a very tough deep learning model, we can also use to classify these things. We can also use the kNN for classify purpose, right? All as well as the regression. So predicting whether a person enjoys a movie, and a movie recommender system, if we need a movie recommender system, we can also use kNN for that kind of things, right? Identifying the pattern in genetic data, right? These are the application part of kNN, right? And the main advantage of kNN is this is very easy to understand, that look, this is not basically a very good algorithm. If you take in the if we consider the time complexity, it's not very fast algorithm. I know that we know that this is not a very fast algorithm. The time complexity and place complexity is not very good, okay, because this is a very primitive algorithm. But for a beginner, if he actually want try to understand the algorithm very easily, that kNN is very suitable for this type of people, right? The algorithm part is very easy for kNN, right? So that is the main advantage of kNN, that is very easy to learn, easy to understand. So it's a very proper algorithm to start with your classical machine learning journey. So for that case, kNN is very useful for a beginner perspective, but it is not very good, very good in the terms of the time complexity, in the terms of the place complexity, right? uh, so so let's move on to the next slide. The kNN algorithm. What is the algorithm? What is the steps behind it? Right. So look, the kNN algorithm begins with a training data set. You need a training data set. Okay, made of with the example that are classified into several categories. Look, this is very simple. We need a label data set. We need a label data set for training purpose. After the training, we assume that we have a test dataset containing unlabeled example that otherwise have same feature as the training dataset. And then for each record in the test dataset, kNN defines k record in training data that are the nearest in the similarity, where k is an integer specified in advanced, right? And then the fourth step is the unlabeled dataset instant is assigned the class of majority of the k nearest neighbor. Now head to me. So the first thing is we need a labeled dataset to train the data, and we also have the testing dataset. We also have the testing dataset. First, train the dataset using this algorithm. So how this algorithm works? First, it calculate when you give a new data point to classify the data point to classify. So first thing it do is it actually calculates the distance between all the points, distance among all the points. This is the first thing it's actually do. So how they calculate the distance between among the points? It's using Euclidean distance calculation method, right? And then it tries to find the nearest point. How can they get the nearest point? This is very simple, because previously we calculate the distance among the points from the newly count data point, right? And then we short the distances, and then we get the nearest point, right? So how many nearest point it calculates? Look, if the k is an integer, if our value of k is 3, then it consider only 3 nearest point, right? 3 nearest point, and then it performs a voting, and then it classifies the things, right? It classifies, it's actually comes under the yes or no, or any kind of level it will get, right? So this is the algorithm for kNN. The first thing is, let me repeat again. The first thing is, we need a label data set, and then we have to train it using the algorithm, right? And then what is the principle, what is the steps in this algorithm? We have to, when we give a new data point to classify, then first point is it calculate the distances. It calculates the distances among the points, right? How it calculates the distances is very easy. It calculates the distance among some formula, distinct calculating formula like Euclidean distance. We know that how we can calculate the Euclidean distance in the 2D points, right? So then it shorts. So we need we get the distance among the points. Now we need to short. We need to short. If our value of k is equal to 3, so it will take 3 nearest point in the basis of distance, and then it uh, uh, performs the voting and try to capture their pattern and classify the newly comes data point, and it will give the output. That is the simple steps of kNN algorithm, right? So that is the example. Look, their ingredient, sweetness and crunchiness are the features, the data set, right? And the food type is the label. Label means output, right? So this is an example of a data set. In that this is a simple example of data set as a label data set, where we have clear input and output column. That ingredient, sweetness and crunchiness is the input column, and food type is the output column, right? And then we try to perform the training on this data set, right? And then kNN performs its algorithm and predict what is the food type. What is the food type of the newly count data set? Is it a fruit? Is it a protein, or is it a vegetable? Try to classify, right? Understood? Look, uh, look how there is two x-axis and y-axis. In the y-axis we get how crunchy. This is actually a graph, right? And we try to find those graph, that how crunchy the food is and how sweet the food is. It's actually the implementation of the previous example. And now look, we get this kind of point. This is the graph, that lettuce, carry, carrot, that kind of things. And then we perform the training on it. We perform a training on it, and then we get this kind of things. Look, this is nothing. What do we do? We actually perform the training, and it's actually calculate the distances and distances among them, and find that nearest neighbor, and try to capture their pattern and properties, and then classify. Look, apples pair after training, and then if we after training, it's actually labeled as these kind of things, that apple, pears, grapes, orange, banana comes under the fruits, and if we bacon, nuts, cheese, fish comes under the protein, and lettuce, carrot, cucumber and green beans comes under the vegetables. How we can calculate this? By using the distance calculation method, and then after that we actually perform the voting. And then it classify and map this kind of classification. Now this is the classification. Now if we try to give any kind of new data in it to classify anything, if it locates there, so it obviously comes under the fruit part, right? If our data comes in this part, so it's actually classified as a vegetable, right? And if we give a point which actually if we draw the graph, and that point is comes under this part, and then it will classify it as a protein, right? So is that clear? Right. Okay. Now, okay, so this is a visual representation of what I have said, that sorry, it tastes like a vegetable. Yes or no? I know the vegetable when it tastes one. The no one tomato is fruit by definition. It's nothing. That this is a visual representation. The visual representation of or cartoonist representation of what I have said earlier. Right. This is nothing but first we have make a dish and make a boundary by calculating the distance, and then we have to classify the points, right? Right. Now look now here, the newly come data is suppose the tomato, right? Now tomato, now look, tomato actually situated there, right? Situated there. Now it will find the nearest points, right? How it can how it can find the nearest point? By calculating the distances. Now it's try to, now it try to calculating the nearest point, like it will make a distance, calculate the distance between that at every point. It will calculate the distance using Euclidean method, right? Using Euclidean method, and then uh, it will perform the voting. Oh, okay, look, there is 4, there is k, the value of k is 4. uh, the nearest points are green beans, which is comes under vegetable. The nearest point is nuts, which is comes under protein. So vegetable gets 1 point, protein gets 1 point. Now another 2 points are grapes and orange. The nearest neighbors are grapes and orange. Grapes and orange, look, grapes and orange comes under fruits. So fruit get 2 point, right? Whereas vegetable get 1 point, protein get 1 point. Okay, so now let me clear this thing. Tomato, like tomato situated there, tomato situated there. Now we try to then it calculate the distance among the whole all the points in the data set, right? It the Now we need 4 nearest neighbor. We need 4 nearest neighbor. What they are green beans. They are green beans, right? Which actually comes under vegetable. They are proteins, which sorry, nuts, which actually comes under protein. So vegetable get 1 point and protein get 1 point. But another 2 neighbors are grapes and orange, which actually comes under what? Fruits. So tomato, so the tomato will classify it as fruits, right? Classified as fruit. So that is the working principle of kNN, right? So let's move on to our next slide, right? Calculating the distances. How we can calculate the distances? Locating the tomato's nearest neighbor requires a distance function or a formula that measures the similarity between the two instances. There are many different ways. I actually try to, when I always saying that there is Euclidean distance, but that's not the only one way. We can use any kind of distance measurement tools, like Kawasaki distance. Traditionally, the kNN algorithms uses Euclidean distance. It is actually obvious that for Euclidean distance calculation is the most popular distance calculation algorithm in this domain, which is the distance one would measure if you could use a ruler to connect 2 points illustrated in the previous figure by the dotted line connecting the tomato to the neighbors. But you know that, I think you know the how we calculate the Euclidean distance. We will understand in the next slide. So go to the next slide. Look, this is how we can calculate the Euclidean distance. The formula is very easy. Root over under x2 minus x1 whole square plus y2 minus y1 whole square, it just comes under the root, right? So this is a simple coordinate geometry, right? This is how we can calculate the distance between 2 points. So again I am telling that kNN, first it calculate the distances, then find, after then find the nearest neighbor. If our k value is 2, if our k value is, sorry, if our k value is 3, it will choose 3 nearest point and labeled as that they are the 3 nearest neighbor for me, and then it tries to it performs the voting and try to capture their pattern, and who wins the vote, it will classify on that. If we have two yes classification and one no vote classification, then it will definitely comes under yes class. Why? Because yes gets 2 marks, 2 points or 2 votes, and no gets 1 marks or 1 point or 1 vote. That's why, right? So the distance is that, look, this is the distance, this is the whole formula for calculating the distance. uh, this is actually comes under the Euclidean distance calculation, the formula for the Euclidean distance formulation, right? And there is a example. The distance formula involves the comparing the values of each feature. For example, to calculate the distance between the tomato, which is sweetness is 6 and crunchiness is 4, and sweetness is 3 and crunchiness is 4, it just this is actually x1 y1, and this is actually y1 sorry, x1 y1 x2 y2, and then it's performed the it performs the formula, and then we get 4.2. That is actually the distance, the Euclidean distance between this point, right? And this is the formula, right? Now this is very easy. This is the formula for Euclidean distance, how we can calculate the Euclidean distance. And we can also use the Manhattan distance, that this is the formula. This is there is no square root. You just perform the mod value, right? If we have the lower dimension, if we have a lower dimension, then we can use that Manhattan. We prefer the Manhattan distance calculation. We can also use the Manhattan distance, but if we have a higher dimension of data, we can use the Euclidean. But Euclidean distance is the most popular, where we calculate the distance between 2 points. And distance calculation, actually kNN is a distance calculation, distance based algorithm. In classical machine learning, we have three kind of machine learning method. One is gradient descent gradient descent based, like linear regression, logistic regression actually comes under the gradient descent based. And the second kind of algorithm is the distance calculation. kNN is actually comes under that. And third one is tree based algorithm. Decision tree and random forest comes under this kind of algorithm. Obviously random forest also, as well as it's a tree based algorithm, as well as ensemble learning. It's a proper special kind of bagging technique, right? Look, this is the visual representation how we can calculate the Manhattan distance and the Euclidean distance. This is nothing but the mod values, you can, and this is the Euclidean distance, which is actually x1 minus x2 minus x1 whole square plus y2 minus y1 whole square, the whole root. Okay, so this is the visual representation of Manhattan distance calculation, the Euclidean distance calculation. So next, go to our next slide. Look, this is how we can calculate the closest neighbor. That is the mathematical representation of that. Look, ingredients, the sweetness, crunchiness, and if we get the new point, and then we calculate the distances, and then we get the nearest neighbor, right? Choosing the appropriate k. There is another question, how we can choose the appropriate value of k. We are saying that if the k is 3, if the k is 5, okay, how we can understand what is the what is the most suitable value of k. Look, if the value of k is very low, like 1, 2, we face the overfitting problem, right? If we have the value of k is very high, like 11, 12, much more, 20, 21. If with the value of k 21, 22, in that cases we face the problem of underfitting, right? So to avoid this kind of problem, so there is one task that we have to properly choose the suitable value of k, right? uh, let's look that slide, that deciding how many neighbors to use for kNN determines how well the maid will generalize to future data. The balance between overfitting and underfitting. Look, I have clearly mentioned that if we the value of k is very low, if the value of k is very low, then we face the problem of overfitting. If the value of k is very high, we face the problem of underfitting. So we need a bias variance trade-off, right? We need a bias variance trade-off to balancing the things, right? So the choosing the proper value of k is one of the most important tasks in kNN, right? So it's actually indicated this thing, choosing a large that reduces the impact of variance caused by noisy data, but can bias learners such as that. This is nothing, this is actually nothing but that it's actually state the bias variance trade-off, which is actually the overfitting underfitting problem. It's actually state that that statement which I have clearly explained. Now, how we can choose the k value? Mm, we can get a loop, right? So k value 2 to 30, and then plot the graph, right? uh, so for that, in that case, error rate will be our we should in our the y axis, right? So if our error rate is very low, in that point the k value is the most suitable, where we get the lowest error rate, right? So we have to plot the graph using the loop. It's very easy. K value equal to we can perform the 100, anything, okay. Then we have to plot the graph where we get the lowest error rate, for which value we get the lowest error rate, that will be the most suitable value for k. Okay, that's how we actually choose the uh, we actually get the appropriate value of k. In that graph we get that, look, if the value of k around 10, okay, 10, 11 or 12, we get the lowest error rate, right? So for that data set, our k value will be 11, 12, that kind of around 11. Okay, you can say that that's 11, because in that point, in that, look, in that point we get the lowest error rate, which is our main motto. We have to minimize our error rate in supervised learning. That is the main motto. So this is actually that lines actually indicates the validation error, right? So this is how we choose the value of k to get the most benefited result, where we get the lowest error rate, right? Understood? Look, in practice, choosing k depends on the difficulty of the concept we learned and as the number of records. Okay. K will somewhere say between 10 to 10. Okay, you can set the value the value of the k 10 to 100, 3 to 100, anything, and then you can also get the graph of get the graph, and then try to get the value where error rate is lowest. That is the most suitable value of k, right? This is how by plotting graph we get the suitable value of k where error rate is lowest, right? Look, uh, that is another point is, if we use the kNN model, that kNN algorithm, we try to use the kNN algorithm. Data preprocessing is the most important part on that, because this is actually works under the distance calculation, right? Distance calculation. Like, without proper normalization standardization technique, we can't apply it, and it's not working as well, right? Because this is all about the distance calculation, right? Distance calculation. So it should, the all data should in the same range or same scale, how we can get the same skill data using min-max normalization or normalization and standardization. What is the formula for that? This is comes under the data pre-processing, right? This is comes under the data pre-processing. That is the formula for min-max normalization, which is x new equal to x min of x by max of x minus min of x. And in that way we get the normalization. Why we need the normalization standardization for distance? This is very important because if our data isn't in the same scale or same range, the distance calculation, because kNN actually works on the distance calculation method. If our distance are not the same range, it can't work properly, it can't get the most suitable output. That's why we need make min max normalization or any kind of standardization technique we need, right? So that's why that normalization standardization process is very important in the data pre-processing part for kNN algorithm, right? Look, there is another point is kNN actually called as lazy learning. Why this is called as because the time complexity of kNN algorithm is very not a very good, right? It's a very time taking and also as well as a very space taking algorithm. Why this? Because it's actually store the whole data set and store the whole data set, and then when it gets the output point, then it try to it's start their training process, it starts their distance calculation process, and then it gives you the output, which takes a lot of time. Because when you give a point, when you give a new point, then it start the training process. What is training process? Is then it start the distance calculation, then it start the find the then it will find the optimal value of k, then it calculates, then it give you the output, right? So that's why it's a very lazy because time taking, it's actually time taking, the time complexity is very high. So that's why instantly merely store the training data in it. This allows the training phase to occur very rapidly, with a potential downside being that the process of making prediction tends to the very relatively slow, right? So that's why this is actually called as a lazy learning, because it's very slow. After getting the new data point, it starts the training process, it start calculating the distance, then it finding the value of k, and then voting, and then it gets the output. So that's why it's a very slow process. Okay, so when you give a new data point, then it start its training process. That's why it's very slow and it's a time taking algorithm. So that's why it's called as a lazy learner, right? So look, strength. What are the strength of kNN? It's very simple and effective. Whatever. It's a very simple algorithm. Just 2 or 3 steps. First, calculating the distance. The gets the optimal value of k. Then find the nearest neighbor. Shorts the value of the distances, which is the lesser distance. It's actually considered as the neighbor, and then it performs the voting, and then it captures the properties of nearest neighbor, and then it classifies the data. It's very simple. That's the strength of kNN. uh, and makes the second stage, they make no assumption about underlying data distribution. Okay, it's very easy. So then you no need a normal distribution, that kind of, we don't in linear regression we need 5 assumption. In kNN we don't need any kind of assumption. And the weakness, what are the weaknesses? That does not produce a model, which limits the ability to find novel insight in the relationship among features. Slow classification phase, it's very slow in the classification phase, requires a large amount of memory. Okay, because it's not a very it's a very, it needs a very space. Okay, it's not a very proper space complexity, right? Space complexity is very high for kNN algorithm, as well as the time complexity and nominal and the missing data set. And so we need the proper data pre-processing method for kNN algorithm. So that's the weaknesses, right? The Python packages we need. pandas, numpy, pandas for the data analytics, and numpy for the numerical computing, like array. If you're working on the array matrix, that kind of things, we need numpy, matplotlib for the visualization, plotting the graphs, and sklearn for implementing the model, right? Implementing the models, we need sklearn for plotting the graphs. So we need a proper visualization. For that case, we need matplotlib and numpy for computing the complex numerical methods, like we perform with complex matrix and this kind of things. We need numpy, and pandas for data analytics, right? Understood? Okay. kNN as a classification, so it's a good, so it's a very it's nothing but which I have discussed earlier. This is the gist of that things, right? This is the data set, that is a very famous data set for how we can classify the iris setosa, that kind of things. Okay. uh, Iris Verska, iris setosa, and iris virginica. This is the simple classification data set. Is a very famous data set. Then we can also perform kNN on this data set to classify these things. Okay. This is the code for that. Look, we first we have to import the dataset there, and then we import the dataset, then assign the columns names, right? Assign the column name on that. That is what are the columns? That sepal length, sepal width. Okay, so petal length and petal width, and then output is class, right? And then we have to perform the training. We look, we perform the training, then we training. Oh, before that we need to train test splitting. Here we get the 10 test splitting. After that 10 test splitting, we need data pre-processing, which I have discussed earlier, why we need normalization standardization technique on that, why these are very important. We actually perform standard killer, right? For standardization part. Okay, so these are the 10. Then import our kNN algorithm and train with kNN algorithm, right? So this is the code for this thing. This is a very basic for in your machine learning journey. So I think you know all about these things for machine learning. Okay, sklearn matrix import for uh, so for experiment, why we need that classification report conflict? So to evaluate our model, so what are the basic steps basic steps of machine learning? The first thing is you have to import data. We do that. So then we tend to split. We also do that. After that, we need data pre-processing, right? We also do that using normalization standardization technique. We have the missing value. We can also sort out things out, right? After that, we can apply the algorithm. Have applied the algorithm, which is kNN. After that, the model is prepared. Now we need the evolution of the model. So what are the results of this model? Because these are classification. This is the example of a classification. That's why we need confusion matrix, accuracy score, that kind of thing, which is by which we can evaluate a classification model, right? So these are these things. Okay, this is the code for these things. Okay, and this is all about kNN algorithm, right? Thank you.